Okay, so when you are given a word problem, you must write let statements. So let x equal and let y equals. You have to make two equations. So you can solve these problems usually using trial and error. That's not what we're aiming for here, okay? So you have to write your own equations, and then you can choose the method you want to solve it. Most people do not pick graphing ever, okay? Sometimes if an equation has the variable sort of already isolated, then they'll choose substitution, but a lot of people often choose elimination, but it doesn't matter. There's not, you're not going to get more marks for doing one over the other, okay? And then of course you need to have an answer statement, and sometimes the word problem will be really specific, so they'll want to, you'll have to make sure that you answer the question, okay? And that's the same for the not the next unit, but the unit after. You have to really make sure you interpret what your x and y value mean. Okay, so if you forget how money works, and I know that that seems like a weird thing to say, but you would be surprised. Okay, so when you're writing a quarter as dollars, then you're going to use 0.25. You are never going to use 25 cents, okay? A dime is 0.1, and a nickel and we don't use pennies. Sometimes you're going to be given values as percentages. So if you forget how that works, like say you have 7%, we are never going to use percentages. So these questions would sort of resemble what you guys would have done over and over again, the word problems in grade 9. Sally works at a store. She makes this much money. Her base salary is this much money plus 10% commission or something like that. Sales tax, right? You do that in grade 9, that kind of thing. So remember, when you are given a percentage, you divide by 100. Now, again, some people will just do that in their head. So percent is always a total out of 100. And you're going to, so that's 2 decimal places. So you can think of it like moving 2 decimal places. Some people will say change it into a decimal, which is fine, but you could be given something like 4.5%. So that is a decimal, but you still have to divide by 100, okay? Okay, so a very common word problem type is called a number problem. So you have to find 2 numbers. Remember, all of our equations have 2 variables, x and a y. And again, you're always going to need 2 equations, just like the systems that we've been looking at, okay? So it will use words, sorry, mathematical words like sum. If you're looking for the sum, what math are you doing? Good. Usually it's just addition or subtraction, which is difference. Product is multiply and quotient is divide, but I don't really think we use those very often. And then one of the numbers will be smaller than the other. So when you do, say you're going to do subtract, if the answer to subtract is positive, then you kind of have to think about how the numbers are going to work that way. So it just says determine the 2 numbers. 3 times a larger number less 2 times a smaller number. That seems a little bit overwhelming first. So if we have two numbers, one of them has to be smaller and one of them has to be larger, and it really doesn't matter. Usually people choose to write x first. So then x will be the smaller number. It can be y, it doesn't matter. That's why let statements are so important, okay? When, sorry, no. When you have a number problem, usually one of the equations is very straightforward. So it just says the sum of two numbers is 45. And then the other equation will require a little bit more brain power, okay? So now we have the second sentence, 3 times the larger number. So that's 3y, less 2 times the smaller number. So that's 2x equals 35. So when you do this, 3 times the larger number, subtract 2 times the smaller number. That's a little bit ugly. So then in your head, you might write it like negative 2x plus 3y equals 35. It doesn't really matter. You're just going to rearrange. Okay, so now you can decide. Most people, especially since one of them is already negative, most people would prefer to do elimination. If you like substitution, do substitution. Okay, it doesn't matter. I will always give you graph paper. I've never had a student pick graphing, but you can certainly graph these, that's fine. You guys want me to read it out to the whole class? I know, but just pay attention. So this one is negative 2. You don't need to do anything to this equation. So we're just going to multiply this one by 2. That's the most straightforward thing to do, unless you're going to do substitution. Both of these variables only have a 1 in front of them. So you could easily solve this one for x or solve this one for y and sub it in. That's fine too if you prefer substitution. When you have a number problem, usually substitution is not that big of a deal either, okay? So, but I'm going to choose elimination this time. So again, decide how much work you need to show. So when you multiply by 2, you have to multiply the whole equation by 2. I'm not going to make any changes to the second one. I don't need to. When you add 2x and negative 2x, you're going to get 0. It's going to eliminate. Two y plus 3y is 5y. 90 plus 35 is 125. Yes. Doesn't matter. That's why your let statements are so important. So then did you get x equals 25? Yep, that's fine. Yes. That's fine. Yep. 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 And think about it logically. So if you have a number question like this is ruthless. So if it said the sum of two numbers is, 107.32. Okay, yes, we could do that, but why? But here it says the sum of two numbers is 45. So logically, it probably makes sense that this is going to be a whole number, right? When we do the money problems, 0.25, 0.1, 0.05, or it's easy to have $10.35, right? That's a decimal. So maybe there might be decimals, okay? So try to think about the logic of your answer. So again, when you do elimination, it doesn't matter which equation you use. This one is significantly simpler. So if you just want to plug it into there, and then it really depends. I forget what the test says exactly. So if you're asked to check, make sure you check. If you have time at the end, maybe you'd want to check anyways to make sure you were right. But when it's a word problem, you want to make sure that you give your answer because X and Y, they have meaning, right? So then go back to your let statements. So therefore, the smaller number is 20 and the larger number is 25. And like Ty said, I made X the larger number, but that's fine. His answer statement should be the same as mine. Okay, so you get the same answer. If somebody had chosen substitution, you should get the same answer. Okay, there's only one point of intersection. Okay, so another type of number problem is one like this one, where one of the equations is actually seemingly simpler, but then sometimes that can then, make things a little bit trickier, which is sort of annoying. Okay, so a number is 5 times smaller than another number. 4 times the small number minus 3 times the large is negative 33. So again, we're going to do the same thing. X is going to be the smaller number or y. It doesn't matter what you want to do. I'm just going to keep it the same. So I'm going to make x a smaller number. Okay, so the larger number y is the same as 5 times the smaller number. So 5 times the smaller number equals the larger number. That's what the first sentence says, and it makes sense. If y is the larger number, then multiplication makes a number bigger. 4 times the small number minus 3 times the larger number makes negative 33. So if the number is negative, make sure you write that down, okay? Because as you know, it can change your answer. So now one of our equations is already in the form y equals. So maybe this time substitution is a little bit more straightforward. We don't have to do any rearranging at all to do substitution. Whereas if you were going to do elimination, which you can, that's no problem. You would have to rearrange this. You'd have to bring the y to the other side. So you'd bring this to the other side. And then what would be left here? Nothing, which we put 0. Okay, so if you're like, what? Then just do substitution. We already have y equals. So in number 2, everywhere we see a y, we're going to put 5x. So it's not even, when you get a question like this, it's not even that tricky of substitution. You don't have to distribute or anything, or you don't have to distribute across addition or subtraction. So 4x, negative 3 times 5x is negative 15x. 4x minus 15 is negative 11x. When you divide, don't lose the negative sign. It's divide by negative 11. And then when you do this kind of question, the second substitution is really easy. Now, whenever we always go back to the other equation, right? So now we just have to sub it into this and just multiply by 5. So not too tricky. Even if you got some sort of wacky answer and you were like, there's no way I'm right, this can't be right. Maybe you tried check, maybe you didn't. But you're either way, let's say you forgot the negative here and you wrote divided by just positive 11, you wrote negative 3 or something. That's like half a mark lost. But if you freak out and then stop here, you're going to lose marks because you didn't write an answer statement. So even with your wrong answer, I'd love to give part marks. So continue on, do as much work as you can so that I can give you as many part marks as possible, okay? And don't screw up your answer statement. Don't write by accident the larger number, or the smaller number is 15 and the larger number is 3, okay? So take a deep breath and make sure that you don't lose marks for the simple, like the simple things that can get you easy marks, okay? Okay. This next question is more like we're basically just combining two of the problems you did probably in grade 9. So a yearbook committee must choose printing company to print the yearbooks. Blue Heron yearbooks charge $8,000 for setup and $4 per copy. Miles Ahead yearbooks charge $8,400 for setup and $3 per copy. Did I say 6,000? 8,000? I need my glasses. How many yearbooks must be printed for the cost to be the same for both companies? So you would have done questions. Philip has a cell phone. His cell phone is $30 a month plus $4 a minute. You would have done questions with sales tax. A shirt costs $15 plus 10%. Sales tax, if you bought so many shirts, what would the price be? Or whatever. Registration, like Tyler has a gym membership. It costs $30 a month plus, 5 times every time he uses it, right? So many of those questions I'm sure you did. So now we're going to do these ones and see where they are better. So a lot of these questions will say how many yearbooks must be printed for the cost to be the same, or sometimes you're given a graph and you have to interpret it, which if you sold 10 yearbooks, which company is more cost effective. So this is actual legitimate math that depending on what kind of path you take, you could have to do. We're going to look at when we get to quadratics maximization. So you can't just charge whatever you want for something. There's this maximum limit to where profit margins will decrease, right? So what would the price be? What's the maximum price I can get based on the cost of making it, that kind of thing. So if I throw anybody, if anyone's interested in physics, you'll do a lot of parabolic motion. If I throw something, what's the maximum height it can achieve? What's its maximum speed? That kind of stuff. So these questions, when you write the equation, they will have the form y equals mx plus b, kind of, because you would have done these last year. So then again, it's up to you. They're going to be in y equals mx plus b, so it's already solved for y. So if you want to do substitution, that's fine. Or you can do a little bit of rearranging or a little bit of thinking and choose elimination. It doesn't matter, okay? It also doesn't matter your x and y values, but that's why let statements are important, okay? So most people, especially if you want it to look like y equals mx plus b, then the y is going to be the end result, the total cost, the profit, okay, that kind of thing. And then x will be how many of them usually. like the rate of change, right? The slope. So here we're selling yearbooks, so X is going to be the number of yearbooks. Usually I'm not super picky about your let statements. So if you choose to write let Y be the cost and you didn't write total, I would not take marks off for that. Okay, so, and it doesn't even really matter, Blue Heron versus miles ahead. If you, like, we just usually label equations 1 and 2. If that messes you up, if you put more words in your solution, that's fine. That might mess you up. You could even put like a 1 and a 2 up here for yourself. We're looking for where they're the same, so it actually doesn't really matter. Maybe you don't want that extraneous information, okay? So we have the total cost is going to be, the base price is, or the setup cost is $8,000, the registration fee, whatever. And $4 per yearbook versus $8,400, but only $3 a yearbook. So like I said, you could do questions like this where it said which one's better. This one happens to say how many yearbooks are going to make them the same. So it's up to you. If you want to do substitution, technically you could even do elimination and multiply, say, this one by -1, and then you would get 0 and you would have X. You could do that. Sometimes people don't like that, like when this cancels out over here, what do I write? You forget that if it cancels out or you get nothing, what do you write? 0, right? So maybe that's not what you want to do. You could rearrange it for elimination. You could do that. But because it's already Y equals, lots of people will just choose substitution. Or they're equal the same thing, so I set them equal to each other. There's lots of ways to think of this. Wherever in this, I said sub 1 into 2, doesn't really matter, but if I'm subbing it into 2, wherever I see the Y, then I put this. So where's the Y here? On this side, so I put that on that side. I could have flipped it around. I could have put 8,400 plus 3x equals 8,000 plus 4x. That's fine too. One thing you can't do with these kinds of questions is trial and error. You have to write 2 equations, okay? So I'm going to bring the 3x over and this over here. So if you read the question, am I done? Have I found the number of yearbooks that must be printed for the cost to be the same? Yes, X is the number of yearbooks, okay? I will never, ever, ever, ever penalize you for doing more work. So if you just keep going, So this is the number of yearbooks and this is the cost. So if you kept going and did that, I would never take marks off, okay? So if you just always want to solve for X and Y, you can totally do that. But technically the question says how many yearbooks? And that's the X value, right? X is the number of yearbooks. And that is the total cost. So when you get to problems that don't resemble necessarily something that you've already done before, one of the things that or sometimes people are like, I don't even know where to start. Sometimes if you go to the end and read the last sentence, that can help you pick what you want X to be and what you want Y to be, okay? The numbers questions that resemble something you would have done over and over and over again in grade 9, maybe they're not so bad. But the other types of questions we're going to do maybe are a tiny bit trickier. Okay, so Adam's piggy bank has 75 coins that are dimes and quarters. The total value of the money is $13.20. How many dimes and how many quarters are in Adam's piggy bank? So this can be tricky because we are given how many coins he has and we're also given the money amount. So how do we decide what to make our X and Y values? So then go, like I said, go all the way to the last question. Okay, we are asked to find the number of dimes and the number of quarters. So we're going to make X the number of dimes. I'm going to do that one first. And then I'm going to say Y is the number of quarters. So the number of dimes and the number of quarters adds up to 75 coins. But then the next sentence says the total value of the money. So then we have to include the money. So again, dimes are 0.1, dollars and quarters are 0.25. So however many dimes we have, we're going to multiply by 0.1. Now, you don't have to write that 0 if that bothers you, okay? And the quarters multiplied by 0.25 is going to give us $13.20. So even though even though the money amount is giving us a decimal place, because our question is asking us for the number of dimes and the number of quarters, can you have half a quarter or half a dime or 0.375? No. So again, think about your answer. Should I get a whole number? Yes, you should, okay? So it's up to you. I did the last few as substitution, so I'm going to pick elimination this time, okay? But you can pick whatever you like. I'm going to use a different color. So I'll use X. All of these are positive, so nothing is super easy. So I want these equations to be equivalent. So I'm going to multiply this equation by negative 0.10, so that they match, but opposite signs. Okay? Okay? So I don't have to change it, because you have to multiply every single one of these by negative 0.1. So 75 times negative 0.1 is negative 0.75. If you just want to write negative 0.75, you can do that. You're just moving the decimal place over. It does not matter. Nope. You know why I picked it? Because it's first. You can choose, if you like substitution, you can choose to do substitution. Doesn't matter. You should get the same answer. I just did the other ones as substitution, so I thought I'd do this one as elimination. Okay? So negative 0.1 plus 0.25 is 0.15. Like Ty said, Philip said, I'm not going to write the 0 here this time. Negative 7.5 plus 13.2 is 5.7. And remember, we want to get a whole number. This question does want us to do both. So we've got the dimes, which is X, but we need to get the Y. So I don't want to squish down here, so I'm just going to keep going up here. But if you have more space, that's fine, okay? When you do elimination, you can choose, but this one is much more straightforward than that one. So most people would pick 1, but it doesn't matter. Okay. This question is a little bit tricky, but again, if you're not sure, go to the last statement or the end of the sentence, and hopefully that can help you decide what you want X and Y to be. Okay? So Maggie drove to Quebec City to visit her sister. She drove for a total of 8 hours and a total of 880 kilometers. So again, now we have two units. We have hours and we have kilometers. So we're going to split those up when you do your equations. If Maggie drove at 60 kilometers per hour on city streets and 120 kilometers per hour on the highway, how many hours did she spend on the highway? So the question is asking us how many hours did she spend on the highway, then the other option is how many hours did she spend on the city streets, okay? Check your let statements are going to answer the question. You could even do it that way. Once we solve for y, we're going to find the number of hours she spent on the highway, which means we've answered the question, okay? So since x and y are in hours, then you can do x plus y. These are hours, so what should they equal? 8 or 880? Good. Then, in order to get kilometers from speed, you can think of it like something called dimensional analysis. So this is where the science teacher in me likes the questions like this. So just as an aside, if you have 60 kilometers per hour and you want it to equal kilometers, because we have 880 kilometers, how do I cancel out the hours? What kind of math do you do? Multiply, divide, add, subtract. Multiply. Right? So you multiply by the hours, and that cancels out the hours, and you're left with kilometers. You don't need, this is like just an aside, but that's how we're going to go from speed, which is kilometers per hour, to get our total of 880. Because we have to, get to that total, right? So if you do, I said X was city streets. The city street speed is 60 kilometers per hour. 60 times the number of hours on the city streets is going to get us kilometers, plus 120 on the highway for a certain number of hours is going to give us 880 kilometers. Okay, so we're going to do, this is kilometers per hour, times the number of hours. Hours cancel. This is 120 kilometers per hour, times the number of hours. So, and this is kilometers. Kilometers, kilometers, kilometers. This one and the one at the end where they're talking about weight and amount, these two are the toughest type of questions. So it's up to you. To change this into elimination is not that big of a deal. You can multiply by -60 or -120 up here. You could do Substitution easy enough as well, so it doesn't really matter. This time I'll solve for y. I'll do elimination solving for y. So this time the y is going to cancel. Negative 120x minus negative 120 plus 60 is negative 60x. So it's a repeating decimal, just round. Can you have a part of an hour? Sure. Can you have a negative hour? Can you go backwards in time? No. Okay, so then you can think about the logic of your answer. The question asks us for the hours spent on the highway, so we want to solve for y. I have rounded, so if you rounded and only did 1, 3, that's fine, but your answer is going to be just a tiny bit different. Is she? I'm very sorry, my sentence is very squished. Therefore, she spent 6.67 hours on the highway. If you rounded that to, 6.67. If you rounded that to 6.7, I would give you full marks. Yes. Yes. Okay, so the next one has to do with percentages. So again, similar to the money one, you have to make sure that you use those as decimals, okay? Divided by 100. So student council has $5,000 to invest. And they hope to earn $330 in interest in the first year. Some of the money will be invested in mutual funds earning 9% annual return, and the remaining amount will be invested in a savings account earning 5%. So we are determining, again, go to the end, the amount in each account, okay? So we're gonna do how much is in the mutual fund and how much is in the savings account. So now you have a choice. You can write the amount in the 9% account. You can write the amount in the mutual fund account, whatever you prefer, okay? Same as grade 9, 70 marks. 70. Your unit tests in grade 9 were 70, right? 70 marks? Yeah, yeah. Technically, each day is like 4 periods of a school day. So we've had 8 periods of school. That's like a week and a day. Now, it's going to be after lunch. Like you'll have the morning time to review. The first lesson of the second unit is not too bad. So at 10:45, I think I'm going to teach the first lesson so that if you're a fast test writer, then when you're done, you'll have something to do. When we're done. Okay, so they have $5,000, so they need to decide how much to put in each. So some will go in the mutual fund, some will go in the savings account, but the total is 5,000. And they want to earn an extra $330. So that's how much interest they want to get. So when you have a percentage, so you're trying to do 9% of the money in the mutual fund, but again, we can't use 9%. So you have to use 9 divided by 100. So the mutual fund, whatever's in there, is going to earn 9% interest. And the savings is 0.05. I'll go back to substitution. Why not? So I'm going to solve for x. I could have picked y. They both have coefficients of 1. Doesn't matter, so I'm going to move it over. You do have to do decimals. Unfortunately, you do have to distribute. So this 0.909 is times 5,000 and the y. You can also think of your answer logically. Do you want to get negatives in investments? No, you don't. And in this case, they're talking about how much to invest. So that would be a positive number as well. A decimal is fine, but it should be a positive number. Okay, so now if you're investing in one account 3,000 and you have a total of 5, then if you just want to if you just wrote the answer here for each account, I would accept that, but if you want to keep the format the same, and don't forget a sentence. I'm running out of room. Okay, write a good sentence. So therefore, there is 2,000 in the mutual fund and 3,000 in the savings. Or if you chose 9% and 5%, that's fine too. You don't have to write the words. Okay, one more. Megan's Candy Store creates their own unique candy mixtures. They mix lemon drops, which sell for $2.50 a kilogram, and red rockets, which sell for $5 a kilogram. What quantities of each candy should be used to make up a 50-kilogram mixture to sell for $4 a kilogram? So again, let's go to the last sentence. It says, or question, what quantities of each? So sometimes we've been counting, but if you think about candies, if you've ever been to Bulk Barn, how do you measure the candies? Usually count out each one? No, you measure their mass, right? Kilogram is a measurement of mass. So you can choose to just use quantities, the quantity of lemon drops, the quantity of red rockets, or if you're concerned that that'll trigger in your head like counting how many of each of them there are, use the word mass. And it says to do each candy, so I'll just do lemon drops because it's first. Let X be lemon drops. Okay, so we want our bag to be 50 kilograms. So the mass of the lemon drops plus the mass of the red rockets equals 50. But then the next one is a little bit tricky. So we want to do $2.50 a kilogram and $5 a kilogram, but we don't know what we want our total to be. Okay? So if we have, so again, you kind of have to do a little bit of an aside. We want the total to sell for $4 a kilogram. How many kilograms are we trying to aim for in our total? Times 50. So we want the bag to cost 200. 4 times 50. Okay? That is a ruthless way to ask this question. I would just give you the total on the test. Okay? I can't remember about the homework questions themselves, but it would be more straightforward. So the lemon drops are $2.50 a kilogram. Lemon drops are X. $5 a kilogram is red rockets. Red rockets are Y. I'll do one more substitution. I'll do Y this time. So 50 minus X. I solved in 1, so now I'm going to sub in 2. Even though this says 5.00, do I really have to type 5.00 on my calculator? No, you can just use 5, right? So you can streamline things sometimes. Oops, that's the answer. Again, you can't have negative mass, okay? So can't have a negative answer. So you can check your logic. So there's 20 kilograms of lemon drops, I just wrote LD, and 30 kilograms of red rockets. Yes, I did 2.5x minus 5x. Like I collected like terms. And then I brought the 250 over.